Good morning, everyone. Thank you for coming. So as Chris said, I am the Digital Repository Manager here at the Museum of Modern Art. And first, a bit of a history lesson. So in 1958, a fire tore through the Museum of Modern Art, destroyed a few works, and unfortunately injured a few people. But this was actually the impetus for the foundation of conservation at MoMA. Prior to this fire, there was no conservation department. Promptly after this, there were two contract paintings conservators that were hired. 2 years later, there was another fire, this time in the sculpture garden. This one was intentional. This is Jean Tinguely's Homage to New York, a self-destructing kinetic sculpture that was performative in nature. So this is to say that we talk about the conservation of time-based media art as a very challenging thing, and sometimes we can talk about these issues as though they are new, but the point is they are not. MoMA and many museums have been dealing with complex contemporary art for decades, and these issues of variability and these issues of what to preserve, what is the artwork. So at MoMA, we have a team of 3 in media conservation. There's Kate Lewis, our media conservator, Peter Alexic, our assistant media conservator, and myself, the digital repository manager. So first, I wanted to give you a bit of a survey of just a few of the types of artworks that we're dealing with here at MoMA. So these are just some of the films of Andy Warhol, and we are in the process of digitizing all of his 16 millimeter. It's about 500 hours of film. Dara Birnbaum's PM magazine. Now, this is a very particular case where this work has had many iterations, many instantiations, and this is a reconstruction of the work as it was originally shown at the Hudson River Museum. And this is currently on view upstairs in the exhibition Cut to Swipe. The 40-part motet by Janet Cardiff, a 40-channel sound-based installation, here as exhibited at MoMA in 2005, here as exhibited in Fort Tilden just this last summer, and here as exhibited in the Cloisters by the Met in 2013. Douglas Gordon's Play Dead Real Time, here as exhibited at MoMA in 2013, here as exhibited by the Tate Gallery, here as exhibited by Docs in Prague in 2009. So as you can see, we're not simply dealing with the preservation or management of assets, we're dealing with the stewardship of variable artworks that can have flexible forms. So we are dealing with the asset management and preservation, but also the management and the preservation of these degrees of change and acceptable levels of change. So beyond these variables in form factor, we also have the variability of equipment. Obviously, I would hope that everyone in this room knows that there's no such thing as, well, it's just a digital projector. There are many different forms, and these all have different flavors, so to speak. We also have the issue of timing and control software. So this is Lovers by Taiji Furuhashi. In 1994, the work was created. As you can see, a whole cocktail of projection technologies, 35 millimeter slide and video, all controlled by 2 DOS computers, custom-built software made by the artist. And even in cases such as this, with the piece HM by Carrie Tribe, which appears on the surface to be a 2-channel film projection, behind the scenes, we have actually born digital audio that is synchronized with the film. Inside one of the pedestals, we have hidden a computer. And then, furthermore, we have truly software-based artworks. In this case, I Want You to Want Me by Jonathan Harris, Shadow Monsters by Philip Worthington, and Long March Restart by Feng Meng Bo. This as well is on view on the 2nd floor in the contemporary show Scenes from a New Heritage. And the very first home gaming console, the Magnavox Odyssey. Additionally, we have things that are web-based and interactive. This is the Wind Map by Martin Wattenberg. So not only here do we have the issue that the work is software-based, but we have the issue that it is looking out to real-time data. Then finally, perhaps the most challenging, we have Tino Sehgal's KISS, 2003. As you can see, there's a lack of any documentation, and this is for a reason. Tino does not allow the documentation of his performances in any form, not even in the form of a written acquisition agreement between himself and the museum. His acquisitions are always on an oral basis. So these works that you've seen occupy a very massive proportion of the collections at MoMA. If you include the film department, these types of works include about 25% of MoMA's holdings. So this is a lot of stuff, to put it frankly. So what have we been doing? Well, basically from 1975 to 2011, this was the situation. Things lived in various different formats in various different places. We had some things stored in Hamlin, PA at our Film Preservation Center. We had some things stored at MoMA QNS, our art storage facility. But then we also had viewing copies, which were a bit more flexible. Some of these would live at people's desks. Some of them would live in our media storage facilities. But in 2011, we started a comprehensive digitization project. So that's the process of getting everything off these various forms of media and in one centralized place, one centralized storage. And while this is a positive step, this is essentially nothing when you're actually talking about preservation. So if one were to take the National Digital Stewardship Alliance's levels of digital preservation and apply this to where MoMA was at after this digitization project, this is how we would be scoring. We were scoring at the lowest level on 3 points, and we weren't even getting on the map in 2 points. And furthermore, access was still challenging. Even though we had everything in one place, these were masters, and this one place was nothing more than storage. There was no software layer for managing rights and access. So that is to say that the level, or the layer rather, that managed access was people. So as you can see, for a curator to access a work, there are various people, various systems and processes for accessing these materials. However, MoMA has been very busy, and today it's really no exaggeration to say that we have entered a new era for digital preservation of MoMA's collections. So if one applies the NDSA levels to where we are today, this is where we are at. We're scoring at level 4 across 4 areas, and for data integrity, we're scoring at level 3. We expect to be at level 4 by the end of the summer. And access looks more or less like this. We have on-demand streaming access to any of the collection's materials that have been ingested into our new system. So how did we do it? What is this system? Well, MoMA has invested heavily in software, hardware, and staffing to support this effort. So let's look at what that is. So we use a bit of metaphors to explain the architecture of our system. So there are 3 essential parts. There's the packager, there is the warehouse, and then there is what we call the indexer. So let's start by talking about the packager. The packager is something that many of you have likely heard of. It's called Archivematica. It is free and open source software made by Artifactual Systems. And what it does is it aids us in a sort of analysis that is similar to what a objects conservator or paintings conservator might do with a physical artwork when they want to understand what it is made of. And the reason that we do this is because there's nothing about a digital file that is inherently informative. Of course, if you want to get very technical, we could debate that topic. But generally speaking, there's nothing about a video file that says, hello, I am a video file. This is my file format. This is my codec. This is my resolution and my color space. You need good metadata for that. So what we do is when we put things through Archivematica, we extract this information and we record it in a very human-readable and machine-readable format, and this gets packaged with the digital collections themselves, so that when we pull this thing out of storage in 20 years, we'll not only know that we have a bit-perfect copy, but we'll be able to actually understand what the heck the thing actually is. So that's a very, very brief summary of Archivematica. So next let's talk about the warehouse. What is the warehouse? Well, the warehouse is a system designed and managed by a company called Archivum, and I need to qualify this by saying this is not yet deployed, but it's something we're deploying in the coming months. So Archivum basically provides what you could call hierarchical storage management. So the system will live on-site at MoMA, and it consists of sort of a soup of various pieces of hardware and software that ties it all together. So most of our storage will become LTO. The large box that's the size of a refrigerator that you see on the right is an IBM TS4500 enterprise tape library. And we also would have a certain amount of spinning disk storage, which would be very fast, and then you have servers on which the software lives that manages all of this. So Archivum software, which is called AStore, abstracts all of this, and it provides just one storage mount. So Archivematica doesn't know anything about the LTO, doesn't know anything about the hard drives. It just knows I have this NFS mount, and I put things here. But what actually happens behind the scenes is that there is one of these complete systems that lives at 53rd Street here, and there is another complete system that lives at MoMA QNS, and these are exact duplicates. It's a whole tape library, it's a whole disk cache, and then we store a third copy at Hamlin, and this copy is offline in the sense that where we get this tape is from our system here at 53rd Street. Because it's LTO, we can actually remove the tapes and ship them off-site. So that's sort of the dark archive. So Archivum comes with a 100% content integrity guarantee that's backed by millions of dollars of insurance. So basically, they not only say, we'll do your file level fixity checks, we'll do it on a policy-based level of checking when you access things rather than just simply linearly going through your entire repository and checking periodically, and we'll do it at a rate that we can actually guarantee that anytime there's a corrupt file, we'll be able to replicate it from one of the known good copies, and you'll never ever lose something. And if you do, we'll pay you for it. So the reason that we went with Archivum is not just to suit our preservation needs, but also to suit our financial needs. So this graph illustrates both the growth and the costs of MoMA storage. So these blue bars here is the growth of our collections in terabytes. And for some context, this is 2025. So this is 10 years from now. We project being at 1.8 petabytes at that point. And this is today, and well, rather, this is really where we're at. But once Warhol begins arriving at our doorstep, we'll be growing at this rate. And so these lines that you see here are comparisons of various storage solutions. So up here, the very highest and most expensive ones, we have cloud-based storage. So if we were to say, try and execute the 3 copies in 3 locations on Amazon S3, as you can see, that would be incredibly expensive. Similarly, Archives Direct, Artifactual Systems, and DuraSpace's partnership that offers Archivematica as a service and cloud-based storage, it's actually a little bit more affordable than storing 3 copies in S3. So now if you were to say, well, Glacier is cheaper, so why wouldn't you do Glacier instead of Amazon S3? Well, there's a good reason, because you can't access things in Glacier. It would be exorbitantly expensive. And even if you were to say, okay, well, we won't access it, it would still be quite expensive. So that's the purple line there. This green line is our current hard drive-based storage, so we're still pretty expensive there, even if we own the infrastructure, and each year we're just paying to add on to it. Archivum is the lowest here. Obviously, this is a no-brainer. Data tape is much more affordable than hard drives. We're talking, double-digit costs per terabyte versus, 3-figure costs per terabyte. And the little bump you see here is when, in 5 years, we refresh all of the tape media and replace with a future generation of LTO, which not only refreshes the media, but it also means that we never need to build onto the TS4500 because we've done our calculations and know that with the future generations of LTO, because the tapes are higher density, we'll never outgrow the base unit of the TS4500, meaning that currently LTO6 is 2.5 terabytes uncompressed, but we're going to skip LTO7, go right to LTO8, and it's going to be quadruple the capacity. LTO, if you're not familiar with it, has a published roadmap. It's managed by a consortium. So in summary, as I said, Archivum meets not only MoMA's high preservation needs, but also our financial needs and how we access things. That's to say, we're a museum. We show things when we choose to show them, or even if we were showing them on demand, we have a very large collection. The typical thing with museums is that what's in the galleries is just the tip of the iceberg. You're only showing maybe 8% of your collection at any given time. So if we don't show things, if we acquire something, exhibit it, and then don't show it again for another 10 years, why would we be paying to store it on high-cost disk storage when we can have it on something more intelligent? So the third part, the indexer. The indexer is software called Binder. And so what Binder does is it's sort of the management layer of our repository. The archival packages that Archivematica makes are very good for preservation in the sense that we know that if we pull this thing out in 20 years, we'll have a very good chance of understanding what it is and being able to prove its authenticity. However, leveraging that rich metadata would be difficult because it's XML, and as we saw, it will be stored on LTO. Even if it wasn't, even if it was stored on online disk, seeing the big picture of all of these archival packages would be quite difficult. So Binder indexes all of these archival packages as they arrive in storage and allows us to see kind of it's a bit like big data for preservation. Binder also allows us to see the smaller picture. It's been designed very much for the use cases of conservation in museums. So we not only in conservation need to understand the very low-level digital preservation, but we also need to understand provenance. We need to know how this file was actually created. If it was from digitization, well, who digitized it? What equipment did they use? When did they do it? And how did they do it? What were the settings on the equipment? So it's really a love note to the future. That's the thing about metadata. So nothing like Binder existed, so we actually built it. We worked with artifactual systems to create this system, and it's Binder in the sense of the way that word is used in conservation. It's not like a binder that you store things in. It's a binding agent that takes our collections metadata, it takes our digital preservation metadata, and it holds it together and allows us to see this bigger picture. So this is very similar to how Archivematica was developed. Nothing like Archivematica existed, so UNESCO, the City of Vancouver Archives, and the International Monetary Fund all ganged together and funded the initial development of Archivematica. It was open sourced and subsequently adopted by many institutions, and today it's become a very vibrant and rather leading edge digital preservation tool. So what I know this says releasing April 2015, and it's now May. So next week, we are releasing Binder as free and open source software on GitHub. So the three parts, the packager, the warehouse, the indexer, Archivematica, Archivum, and Binder. So where are we actually at? Well, Archivematica and Binder are in production at MoMA. They have been for about 5 months. And luckily, due to our particular setting, conservation is very, what you could say, high touch. By the time things are ready to go into storage, a conservator has already condition assessed, they've already cataloged it in our collections management system. So things have already been arranged at a level that we can actually automate the ingest process completely. So right now we're using a tool called Automation Tools, made by Artifactual Systems. It's another open source tool, and it allows us to automate the process of ingest in Archivematica. We basically set our policies. We say, well, when you get this format, this is what we want to do, and when you get this format, this is what we want to do. But just go to town, and if you encounter a problem, send us an email and let us know. So that's essentially what's happening right now, and it's a bit like moving from one warehouse to another. It takes a long time. But the cool thing is, now that we have all of these systems in place, we actually have data and information on how long these processes actually take. And that allows us to say, okay, if we're getting 500 terabytes of digitized Warhol films, how long will that take? And if that's an unacceptable duration, then we can look at optimizations and where we can fine-tune the process. And through analyzing the data from Archivematica, we can actually look exactly at where the bottlenecks are. So just to reiterate, this is where we were in terms of the NDSA levels. This is where we will be by the end of the summer. This is where access was. this is where it is today. So let's talk about access. Access is primarily happening through our DAM, not through Binder. So our DAM is net exposure, and we integrated with Archivematica. So basically in Archivematica, there is now a upload to NetX feature where basically all it does is it takes your dissemination information package and it puts it in a watch directory that NetX keeps an eye on. And Archivematica also passes along a small amount of metadata, and that gets ingested by NetX. So to summarize, MoMA is in a very good place right now. It's sort of like we've got the glass vitrine over the floppy disk. We feel very good about the future safety of our collections. But now, just to conclude, I have this little video, and I would actually like to show you a bit about Binder so that you can understand perhaps how you could adopt and modify or borrow it for your institution. The first thing you see when you log into Binder is your dashboard. Here you get real-time activity feeds. For instance, things that have been recently packaged and placed in storage by Archivematica, files that users have recently downloaded, as well as a widget that monitors the authenticity of the files in the collection. You also get real-time statistics about your digital collection. At MoMA, we have 7 curatorial departments, and so we have a widget that displays the breakdown of which department has the most material stored in the repository. Other widgets include a chart showing a breakdown of the video codecs and file formats in the collection, graphs indicating the monthly total of archival packages to have been stored by Archivematica, as well as charts showing when the works in the repository were actually acquired by the museum. We can search for artworks in the collection from the navigation bar at the top, or we can simply choose to browse freely. As you can see, Binder provides several different levels at which one can browse your digital collections. First, we will browse at the level of the artwork. Many of the filters that you see on the left-hand side are not related to digital preservation per se, but are general collections metadata, such as classifications, curatorial departments, dates of acquisition, and creation. At MoMA, we pull this information from our collections management system. Below these filters, we begin to see filters that are about the archival packages and the digital collections themselves. We can filter and limit searches by when the material was processed, by how big the archival packages are, by the file formats, by video and audio codecs, as well as by various characteristics of digital video and audio material. To browse at different levels of granularity, such as the archival packages or individual files, one need only click the tabs along the top of the screen. At the level of the archival package, we are given a different sort of interface that allows one not only to filter results, but also to sort. The interface for file browsing also offers filtering abilities similar to the other browse modes. However, one can view files directly. Now, let's do a basic search and take a look at an artwork record. Here, I will search for the last name of artist Harun Faraki. This view is where one can find all of the detailed information about the various components of an artwork that has files stored in the repository. The first thing you see is the main image and basic collections metadata about the artwork. We pull these in automatically from our collections management system. Below this is a graph interface of the artwork's components, and the relationships between them. This is a critical tool for understanding the role of the given digital material in the context of the greater whole that is the artwork itself. The context browser offers two core basic features, describing relationships between nodes and building a specific hierarchy and arrangement of nodes. This graph is also the interface to the archival packages that contain the digital objects. On the right-hand side, we see a listing of the files that are attached to the node we have selected in the graph. Clicking the video file here opens the Digital Object Viewer. The Digital Object Viewer provides access to browser-friendly proxies of the original objects, and alongside this, we display the detailed technical characteristics of the file being viewed. We can also multi-select a few files and compare their technical characteristics. Files are also listed in a basic fashion below the context browser. Here, users with proper permissions can download the original master files. Access to original masters can be controlled through Binder's granular user permission settings. Oftentimes, artworks will have some kind of software dependency. For instance, an artwork may have a component that is a piece of executable software and only runs in a particular operating system. When this is the case, we describe this dependency and actually collect and preserve the given dependency. For an example of this, let's search for the artist Paul Chan and select his piece, First Light. In this particular case, we would like to indicate that the software component of this work requires the Windows operating system. Note that Binder is auto-suggesting some values. This is because we have cataloged and preserved various MoMA licensed copies of the Windows operating system. Lastly, let's take a look at the reporting functionality that Binder offers. Binder offers both high-level and very low-level or granular reporting of incoming material that has been added to the repository. Downloaded material that has been downloaded through Binder's user interface, as well as reporting on the very detailed file characteristics and reporting on the periodic checks on the authenticity of the files in the collection. Aside from being accessed in the browser, these reports can be downloaded as CSV files. At the very core of Binder is a very powerful REST API, which exposes all of the rich information contained in the archival packages that Archivematica produces. This opens the door to interfacing with other tools, applications, and systems. Binder serves a critical role in managing the preservation of MoMA's digital collections, and we are so thrilled to be releasing it to the world as free and open source software. For more information, see binder.readthedocs.org and github.com/artifactual/binder.